okay attempt number. Like, I think I'm up to 14 right now, maybe? Yeah? Okay. This has taken a lot longer than I thought. It's taken like 3 days to try to record these videos. I feel like I'm going a little haywire here. You'll hear my kids in the background. They're playing with these big rocks that are like half the size of their head. Like, definitely bigger than a fist. Probably like 2 fists. Bigger than 2 fists. Anyways, they'll be fine. That's their rock collection. Yeah. So what I want to do is I tried to record a video, and I posted it on Blackboard. Oh my goodness, that was a lot to try to do, but this is the same topic, and I just wanted to kind of clarify a few of the topics and just try to get you used to this format of teaching. Yay! I think I might like this type of style. But I am outside, so you will probably hear some of the wind, maybe some cars driving by, probably a cow mooing. They're like, I don't know, 10 yards away right now. And if a dog barks, I will pause and stop the video and try to cut out the dog barking because they're loud. But parabolas. So I want to go to parabolas. Parabolas they're sneaky. Parabolas are easy, but there's so much about them that it makes them a really intimidating subject once you're like finally starting to hold on. Koshi. My dog Koshi is sitting right next to me, and the cows are walking by, and so he's gonna try to bark, and I'm gonna try to stop that. Sorry about that. But yeah, quadratics are, they can be really intimidating. So what I want to do is try to look at a couple different topics, not topics, but a couple different points about them. And now I have my papers between the chair's legs. So if the camera moves, it's because I accidentally hit the leg of the chair. Now we have 2 types of forms of your quadratics. You have ax squared plus bx plus c. That's your standard form. Your highest power comes first, and then it's decreasing in order. And then you have your vertex form. I call it vertex form. I don't think that's like an official name or anything, but it's the vertex form because here you have h and k, and your vertex is the coordinate x comma y is h comma k. So h is your x coordinate, k is your y coordinate. Yeah. Oh, Chris is looking at me like, I don't know. I accidentally made that a plus sign, so I'm going to wipe that out real quick because that's a minus. It's x minus h, and that's really important that it's an x minus h, so I'm going to wipe that out. There we go. X minus h. So the h value right there, that's your x value of your vertex, and k is your y value of your vertex. The a is the same. Where's my highlighter? This a is your leading coefficient. This a is the same a. So a is your leading coefficient. If you have asked me a question, I can't pause this, so okay. And I don't know why you're standing there. So a is your leading coefficient, and he is really important, and we're going to see this in chapter 4 with other polynomials, just random polynomials of any degree. So this is really important. So your leading coefficient tells you whether your right-hand side goes up or down. So if a is negative, whenever someone's negative, you say that they might be sad, right? They might be sad. And if you're sad, you have a frowny face. Sad. Frowny face. See the frowny face? Okay, so that frowny face is called concave down. If your a is negative on a polynomial, it means that the right-hand side, the right-hand end behavior, goes down. Okay? The right-hand end behavior goes down. So this is called the right end behavior. Anyways, he goes down if you have a negative leading coefficient. Now, I left a space here because this point right here, that point right there is your vertex. And your vertex, see how he's at the top of the mountain? See how it's a little mountain? And he's at the top of the mountain. So that vertex is a maximum. It's kind of counterintuitive. You're sad, but you have a maximum. Anyways, so if your A is negative, right? Less than 0 means negative. You might have a big frowny face. And if you have a frowny face, you think about it, your vertex would then be at the top of the hill, king of the mountain. And that's a mountain. That's a maximum. And that's called concave down. Now, let's switch over to, I'm going to draw a line. I wasn't sure where I was going to have to draw that line. Now let's switch over to purple. What if your A is greater than 0? If A is greater than 0, what number is greater than 0? 1 is greater than 0. 2 is greater than 0. 500 is greater than 0. All of those are positive numbers. And when someone is positive, you might say that they're happy. Yay, happy. And what's a happy face look like? Happy face. Whee! There's a happy face. Now, he's concave. He's called concave up. Okay, and then we look at the vertex. The vertex is at the bottom of a valley, right? And so he's called a minimum. Minimum. Now, concave up. So your end behavior here, your right end behavior, is over here. So if A is positive, your right end behavior goes up, and that is for every single polynomial, okay? If your A is less than 0, meaning negative, then your right end behavior goes down, okay? So that's for every single polynomial. Your right end behavior will go either up or down, depending on if your leading coefficient, your leading coefficient is positive or negative. Now, let's look at proper use of terminology. I already have some stuff written out. So f of x has either a maximum or minimum of something at something. So what do you fill in those blanks? Well, your max or min is the y value. And the y value of your max or min, let me switch to a different color. Your y value is this number k. Okay, so he is your max or min. So you have a max of k, or you have a minimum of k. And what does it happen? It happens at an x equals value. It happens at x equals h. So this value, your max or min, your max or your minimum, happens at a y value. Okay, I'm sorry, not at a y value. It happens, it is the y value. Your max or min is the y value. Let's maybe write that down. Max or min is the y value, is the y value. So the max or the min is the y value, okay? And it happens at x equals h. So x equals h, that's just like a side note. He's not really even all that important unless you're talking about applications, and then he's super important. So your max or min is k, whatever that is. So it has a maximum or minimum of k. Now, let's look at example 4. Example 4, I wrote a whole bunch down. Yay! So example 4, scoot this over a little bit. Whoops, you couldn't see that it was at x equals h. Sorry about that. I'm going to have to try to figure out a little more adjusting. So example 4, I'm going to do 2 ways. Example 4 is on page 194 in the book. It's 3.3. And I'm going to do it first by completing the square, and then I'm going to do it way number 2. So this example actually only asks for, let me grab the handout. This handout. So we did this handout in class. It's titled End of 3.2, 3.3, and we had done solving quadratic types in class the lesson prior, and in this class day, when we actually were in class, we started on 3.2. We started on the applications. Remember, 2 trains leave a station at the same time. One goes west, the other goes south, blah, 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 blah. I don't know why they always have trains and math problems, but they do. Hey, ignore all the junk in my yard, but here, you can see the mook house. See the mook house? Woo, he's running. Woo, they're running. Okay, the big ones never run. It's usually the little ones that run. That was my charging cable in the little Mukau. He's going again. The little Mukau likes running up that pile of dirt. They always run up the pile of dirt. It's really cute. So anyway, so that's where we started on that day that we got this handout. And then we did in class, we did example 1 and example 2, but we skipped 3 and 4, I believe. So that's why I wanted to start on example 4 and then maybe do example 3, because example 4 is a little easier. See how A is just -1 and this A is -2. That causes a little bit of problems. But this example is only finding the vertex, axis of symmetry, max or min, and then sketch. I'm going to change the sketch to maybe find the range. But anyways, so the book does this straightforward. They don't complete the square. What I want to do is I actually want to complete the square on example 4, okay? Because there's a difference. See on example 1, A is 1, B is -1. My mom's messaging me. Okay, so here, our A value of -1 is going to make a big difference, okay? So let's look. So the reason why it's going to make a big difference is because you have to factor them out. So here, we're going to complete the square. So here is our f of x. I'm going to highlight him. So our f of x is -x squared plus 14x minus 47. You should write that down. -x squared plus 14x minus 47. We want to complete the square. So our goal for completing the square, let me move my camera over, is it looks like this: a x minus h squared plus k. So we need to know what is a, -1, we already know that. What's h and what's k? So way number 2 will tell us h and k right away, okay? But we're going to complete the square to find h and k first. Why? Because this example is not that difficult, and you really do need to know how to complete the square if you are going to be going into calculus, okay? Okay, so first, if our a was 1, we would compute b over 2, but our a is not 1. So the very first step, we have to factor out a. Then we compute b over 2, okay? But we have to use what's in the parentheses. Why? Because we just factored out a. So when we factor out a, we're going to have parentheses. Third, add and subtract b over 2 squared. These are our typical instructions. So if our a was 1, we would do compute b over 2. If our a was 1, we would add and subtract b over 2 squared. I can't highlight worth anything right now. And then we would rewrite using the x minus h squared notation, and then that would be it, okay? And then we would basically be done. So this is all if a equals 1. If a equals 1, you only have to do what's in the highlighted area, okay? Compute b over 2, add and subtract b over 2 squared, and then rewrite using that notation. However, we don't have a equals 1, so we have a couple extra steps. So we have to factor out a, compute b over 2, b over 2 squared, rewrite, and then we have to distribute the a, and this is the hard part, distributing that a to get it in that notation, and it's really not that hard. I'm going to use colors to show you how to do this. Wow, it is like message time forever. Okay. I keep getting text messages. So now we have, so I'm going to start with this, and I'm going to work through this. I think I want to, yeah, I'm going to start on the next page, okay? Ready? Go! So I have, this is example 4, and I'm going to write down, he's on page 194 in your book. He is f of x is -x squared, I don't remember, plus 14x minus 47, plus 14x minus 47. So our very first step, so we want, I'm going to write down our goal is f of x equals a, x minus h squared plus k. I'm going to underline a, h, and k because we want to know values for those. And this is by completing the square, okay? Let me readjust my camera. There we go. So our first step, so this is going to be my solution. My solution is I'm going to factor out A. Factor out A. Well, what is A? A is -1. So I'm going to factor out -1. So I have f of x equals -1 times x squared minus 14x plus 47. Remember, when you factor out a negative, the signs change. And then my second step is I need to compute what is b over 2. Well, b over 2 is b. Okay, so here's the big deal. If we factor out an a, we are now only looking at inside these parentheses, okay? We're only going to look at that right here. So now our b is this -14. So the b that we're going to use is -14. And that's over 2. Okay? So our b is going to be -7. And then I'm going to go ahead and do step 3. What's b over 2 quantity squared? Well, that's -7 squared, which is a positive 49. So my step 4 is going to be add and subtract that b over 2 squared. But since we factored out a -1, we have to add and subtract this inside the parentheses. Okay, add and subtract inside the parentheses. So let's rewrite this. So f of x equals, I'm going to write -1. I'm going to rewrite what's up here. Okay, I'm just going to rewrite him. X squared minus 14x plus 47. Then x squared minus 14x. What was b over 2 squared? 49. I need to add and subtract 49. I'm going to add 49 and subtract 49. And that plus 47 is going to follow along. Okay? Now, why did I do that? Well, let me grab a highlighter and highlight in yellow. X squared plus 14x plus 49. This is a perfect square. I can rewrite that. That is my perfect square of x minus 7 squared. Right? What's x minus 7 squared? If we do x minus 7 times x minus 7, you'll get x squared minus 7x minus another 7x, which is a -14x. And then 7 times 7 is 49. So that yellow box is the same as this yellow box. Ooh. So all we did was rewrite it with a different notation. Now, we didn't use the -49 or the 47, so when we combine those together, we get a -2, right? 47 minus 49 is -2. Now, here is the tricky part. So I'm going to rewrite the same thing, okay? So in this first step, all I did was rewrite it. In this step, I changed the notation. I changed the notation to x minus h squared. Now in this next step, all I'm going to do, I'm going to actually skip a line. I'm just going to rewrite it because I want to use color to show you what's going to happen. -1, I'm going to use a bracket, and then x minus 7 squared minus 2. So all I did was rewrite it, right? Now I want to highlight this x minus 7 squared because he's one term. And the x minus 7 squared is being, that minus 2 is being subtracted. 2 is being subtracted from this x minus 7 squared, right? You see that? Now, what we want to do is we want to take this -1 and we want to distribute him to this first term and then distribute him to the second term. So when we distribute that -1, we get -1 times x minus 7 squared. -1 times -2 is a positive 2, and that is our answer. There's our a. We already knew a was -1, right? A is -1. And then h, x minus h. So h is 7, right? Because the minus sign is in the formula. Minus sign's in the formula. So this h is our 7. And then plus k, k is 2. Now, what we can do with this information, so I'm going to maybe write this f of x, and I'm going to put him in a box. What I want to do with this is I want to write down, our question was asking what's the vertex? Well, it's h comma k, 7 comma 2. What's the axis of symmetry? Well, the axis of symmetry is an equation, x equals. Well, what does x equal in the vertex? X equals 7. And then, what was it asking? Max or min? Do we have a max or a min? We know. I'm going to take a break here. Here, max or min. And I actually do want to sketch it. I said I didn't want to sketch it, but I do want to sketch it. So here, I'm going to, what's our axis? Over 7 up 2. So we, over 7 up 2. So we go 1, 2, 3, 4, 5. There's 5. 6, 7, 8, 9. Okay, and then up 1, 2. So over 7 up 2. Here's our vertex. I'm going to label it a V. Now, do we open up or down? So we look at our A value. A is a -1. And what happens if you're negative? You might be sad, right? You might be sad some of the time. So, so our parabola probably looks something like that. Okay, so it opens down because A is negative. A is a -1, so it's less than 0. So it opens down. So it's concave down. So do we have a maximum or a minimum? Well, it's at the top. The vertex is at the top, so we have a maximum. So a maximum, the maximum is y equals 2. The maximum is 2. The maximum is 2. Okay. There's our other information. And if we wanted to ask our range, what's the range? So if we took a flashlight and we shined our flashlight, there's our little flashlight, shined our flashlight this way, and then shined our flashlight this way. Okay, shined our flashlight. What would be shaded on the y-axis? If we shined our flashlight, I'm going to switch colors real quick. My markers are going to dry out because I just keep leaving them open. We shined our flashlight. This 2 would be shaded. All of this would create a shadow on our y-axis all the way down. So our range would be everything y is less than or equal to 2. And remember, how do you write that in interval notation? Interval notation would be everything down from -infinity all the way up to 2. So we would have all the way from -infinity all the way up to 2. 2 gets a bracket because he's shaded, and infinity always gets a parenthesis, okay? Plus or minus, infinity always gets parentheses. And if you have a closed circle, you get a bracket. Okay. Okay. I think that is all on this problem. Yeah. Okay, so let's go to the next one. So this is already a 23-minute video. Oh, 2 weeks of being off. I'm already tired of teaching. Not tired of teaching, tired of talking. Silly. Oh, goodness. Okay. So I promised you we would do this 2 ways. The second way, I don't think I'm going to actually do example 3. I think I'm going to leave that to y'all to do. Example 3 is also in the book, so you can look at it. I think page 192. I should write that down. Where's this at? So example 3 you can do on your own. It's on page 192 in the book. Ooh. I'm sitting cross-legged and my foot fell asleep. Oh, goodness. Right, the shortcut way. Okay, so way number 2 is kind of a shortcut way. I don't like calling it that because then people always just want to skip straight to that, and that's not actually the most effective. But example 4, and it's not very beneficial if you don't know how to complete the square. But it's also not the end of the world. So example 4 that we just did, this is way number 2. So this is way number 2. And all we want to do is find out the vertex, Okay, so part 1 is vertex, and that is actually pretty easy, so I'm just going to skip a couple places. Number 2 was what's the axis of symmetry? Also easy. Number 3 was do you have a max or a min? Also easy, but let's skip a couple so we can write down what and why. And then number 4, the range, which we've already discussed, so I may just skip that part. Okay, the vertex. How do we find the vertex? Well, the vertex has a formula. The vertex, x equals h. H is negative b over 2a. Okay, x is h equals negative b over 2a. So b is 14, so we have negative 14 over 2 times a. A is negative 1. Negative over negative, cancel out, and you get x equals 7. Now, if you have x, how do you find y? Well, given a function, if you have x, you plug in x and you get back y. So all we're going to do is plug in x equals h, and we get back y equals k. Okay, that's an important little thing to know. So we plug in x, and we get back y. And on a vertex, you plug in h, and you get back k. So here's my f. So I'm going to plug in f of 7, right? I'm going to plug in h. So everywhere I see x, I'm going to plug in 7. So I have negative 7, 7. I have no idea what's happening over there. My kids are stacking rocks on top of a board that's like taller than they are. And I think a rock just fell off. And it's making Kevin mad. Because I heard him say, and there are no more. I don't know. My husband's over there. He'll figure it out. Okay, so here we have negative 7 squared plus 14, 7 times 7 minus 47. This right here is what I want to point your attention to. Negative 7 squared versus negative 7 squared. We have this one, okay? The negative is not inside parentheses. This just fell on my porch. Negative 7 squared, the negative's not in parentheses. This would be if you had the negative inside with your x, but we don't, right? So the negative's outside. So here, when we type it in the calculator, if we type just this into the calculator, you should get back negative 49, okay? So you type all that in and you get back 2. So there's our y value. There's our x value. So our vertex is h comma k equals 7 comma 2. Yay. Okay. Axis of symmetry is just the x value. X equals 7. That's it. It's a line. You need the x equals because it's a line. So you need the x equals. You can't just write 7 because it's not just one value. It's an entire line. X equals is an entire line. Okay, let me go back and show you. There we go. There's my graph. X equals 7. X equals 7 is this entire line right here. That's x equals 7. Okay, x equals 7 is that entire line. And you can see how it's symmetric. You can fold it over that line. That's the axis of symmetry. So it's the entire line, x equals 7. So let's go back here. Max or min? Well, we already discussed that since a is negative 1 and that's less than 0, it's negative. Negative. So your parabola opens down. And if your parabola opens down, you have king of the mountain, which is a maximum value. Okay, so we have a maximum. And the maximum is, what was the y value on that? 2. And it happens at the x value of 7. So the maximum is 2, and that's it. So this at x equals 7 is kind of just a side note. So the maximum is 2. The range, we already discussed the range. The range is everything going down from negative infinity all the way up to the y value of 2. So your range is y is less than or equal to 2. And if you draw that on a number line, just to remind you, here's 0, 1, 2, 3. You would shade 2 in. You would shade all the way down to negative infinity. Shade, 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 shade. And then you could translate that into interval notation. Interval notation. Starting at negative infinity, going all the way to 2 with a bracket. So your brackets and your filled in circle go along with anything with an equal sign. Okay, if it's less than or equal to, greater than or equal to, less than or equal to, greater than or equal to, they get brackets. And they get a closed in circle. Okay. If you had strictly greater than, strictly less than, you would use parentheses and it would be an open circle. Your infinities always get parentheses, always. Okay, so that's a quick interval notation. Interval notation notes. I'll draw a squiggly line. Okay. What's next? So I think that's about it. That's all on, no, it's not. It's not. Okay, I'm going to pause though, and then I'm going to start another video.